On to the gas giants, the Jovian planets. Jupiter is the largest of the 4 gas giants in our solar system. And actually, Jupiter, if it was 60 to 80 times larger when our solar system was forming, we would have actually had 2 stars. So that's kind of neat. Actually, there are a lot of star systems out there where there are multiple stars that are born together. So, some features about Jupiter. Wow, Jupiter's beautiful through the telescope. It is definitely beautiful through the telescope. And one of the things that you can see through the telescope sometimes is the Great Red Spot. Okay. There is software out there to know what the timing of the Great Red Spot is. Now, you can hopefully see kind of we have some light colored belts and zones. Jupiter is striped, and you can see that kind of that striping through the telescope. What happens actually is that we have alternating regions where the air is going this way or the air is going that way, the atmosphere of Jupiter. That is so cool. And we think that actually kind of that going both ways sort of thing is what has created or has the potential to create regions like the Great Red Spot. The Great Red Spot has been around for hundreds of years. And it's been in the news the last 6 months to a year, maybe, that it's getting smaller, but who knows? The Great Red Spot's kind of like a hurricane on Earth. Let's see. Jupiter has all of the gas giants have a lot of moons, and here are 4 of Jupiter's largest moons that Galileo saw back in 1600s. So Galileo saw these through his telescope. So here we have Io, Europa, Ganymede, and Callisto, kind of in the order as they are from then Jupiter over here. So Galileo saw those. The thing about these moons, or moons in general, around the gas giants is if you're going to send a spacecraft up to visit these planets, you're probably going to want to land on a moon, not on the planet, because the planet's just covered with gas. Let's see. Here I have something about the clouds in the surface, the clouds in the atmosphere of Jupiter. They have those cool colors actually due to nitrogen and I think carbon-containing compounds, sulfur-containing compounds, make those pretty colors. And here's the Great Red Spot for 300 years. What else do we have? On a given night, if you're able to look at Jupiter through the telescope, oftentimes you can see actually the Galilean moons. These are the Galilean moons, the 4 moons that Galileo saw. You can actually see those reflecting sunlight too. Let's see. On to Saturn. So I guess the most notable feature of Saturn is its rings. But we're going to see that all gas giants and all Jovian planets like Saturn, Jupiter, Uranus, and Neptune, they all have rings. Just Saturn's is the prettiest because we think they're probably the most recently formed. Saturn has, like I said, if you're going to go visit a Jovian planet and you want to land something, you're not going to land anything on the Jovian planet, but you might land it on the moon. So one of Saturn's many moons is called Titan, and here's a picture of Titan. These are both pictures of Titan. We actually have successfully landed, I wasn't a rover, a spacecraft on Titan, and took these pictures before probably the environment finally killed the little spacecraft. But Titan's very cool. Let's see. What else do we have? We have a couple other moons that orbit. This looks like Enceladus right here. And this moon actually, if it's the one I'm thinking of, or actually this one right here, Enceladus. Maybe they're both Enceladus. You can kind of see these. These are actually water geysers that are from the moon that orbits Saturn, spewing material into outer space, and it crystallizes. I just think that is so cool. This down here says that if you're wanting to look at the rings of Saturn, like this, beautiful images of the rings of material that actually orbit the planet of Saturn, you're going to want to make sure that Saturn is kind of in the right tilt relative to the Earth. Sometimes we see the rings, what we call edge on, and there's not much to see. Sometimes the rings are a little bit more face on, and they're a little more striking. So Jupiter and Saturn kind of go together. They have that kind of salmon color because of similar chemical composition of their atmosphere. And Uranus and Neptune are the blue guys. And they're both blue due to the presence of methane. The formula for methane is CH4. So that's what makes them blue. Uranus is closer than Neptune. Now Uranus, a lot of times you'll see it. Does this look like it's kind of tilted? Okay, if its axis of rotation is kind of what we say almost lying in the plane, it kind of spins this way. Okay, and you can kind of see here it's tilted and kind of spinning. Now, I told you that all gas giants have rings, and you can kind of see these rings here. They're not as obvious as Saturn's rings, but they are there. Yeah. So then the last planet in our solar system, the 8th planet, is Neptune. Neptune's blue also due to the presence of methane, and sometimes because of its the shape of its orbit is elliptical. We talked about that because of Kepler's first law. Sometimes Neptune is actually further out than Pluto in its orbit. So here is an image of Neptune. Okay. Now Neptune has a great spot. It's actually called the Great Dark Spot. It's actually had a great white spot too. It doesn't last as long as Jupiter's Great Red Spot, but it's just a storm in the in the atmosphere of Neptune. Let's see. The winds on Neptune in its atmosphere are the fastest in the solar system. Is that not cool or what? And so with the gas giants, we have some interesting things going on with their moons. So the Jovian planets all have these moons. This is one of the moons. I don't know if you're into cantaloupe, but does this look like cantaloupe? Okay, so the cantaloupe kind of feature of Triton, this is Triton, kind of is up here. So with regard to both of those cute little blue planets, Uranus and Neptune, you can see them through the telescope, and I've seen them through the telescope, but they are just kind of a blue, sort of kind of small disk.